So let's see. Again, every time only k number. So my first thought on this problem is to use a priority queue, and but it takes a lot of time when we want to delete a number from it and then insert number. Although the lookup is really quick. So actually now we are not using just a priority queue. We are using the monotonic queue. Since using monotonic queue, we can, so every time we have a new number, we pop out all the number that is smaller than it to the queue. So we can keep the queue in a descending order. So every time we see the top element in our queue is about to leave our window, then we can pop the first value. And whenever a value is is ready, we can just append it to the queue. After removing all the numbers smaller. Oh, okay. So let's just take an example here, maybe. So we okay, just was so our queue here. Okay, I'm queue 1. We just put with 1. Right, but then we meet 3. Oh, okay. And because the yeah, I think because the k 3, so still we need to maintain the monotonic queue 3. Because of pop move 1, we add 3. Next one is smaller than it. Okay, we add it to it, and let's see. So now we're at 4. So 4. So 4 -3 to 4. Let's see. Is greater than k. And I mean minus k. K3 is 1. So we pop the window is popped. The window is 3. No, it's 1, 3, -1. So we pop this, becomes 3 and -1. This is a window. Add -3 to this. And for the monotonic queue, we need to append this down because it's smaller than -1. Then I is 5. Okay, wait a minute. So now result should append 3 because we start because I is larger than k. I is larger than k. Actually, when we reach here, we need to start to do that. I is 3. I is 2. Oh, okay, I'm sorry. Here's 3. That's 2. Okay, 2. Actually, 2. We can start. Greater equal to k. We start to append result. I is like greater or equal to 3, we start to pop. And next time I is 4. 0, 1, 2, 3, 5. 0, 1, 2, 3, 4. Oh, it's 4. 4 is that's 5. We first pop first, and we see it's 3. So we need to pop left MQ, monotonic Q. So we have -1 and -3. Now we fix MQ by adding, removing the -1, -3 because they are smaller than 5. Okay, now MQ is 5. And for this window, it's 5. This window is 5. And here is 3, 3. Now here as 3 out is 3, 3, 5. Looks like it's correct. So let's implement it. Okay. First MQ is collections deck because we need to pop left and pop right. And let's go through the numbers. Range and let's just enumerate. Index current number. Okay. So let's see. Okay, I'm the result. The first thing to do is we need to append this to the MQ. Right. So while MQ if MQ has value, then and MQ, the last one is smaller than current number. Okay, then we do pop. Now there's no value smaller than, so MQ can append our current number. I think let's do one more thing. So if our index is greater than which number? Greater or equal to k, which means we need to pop. Not pop left, not MQ. The window should pop left. We need to check. And this index minus k and nums index minus k is equal to MQ negative MQ0 MQ end. No, MQ dollar. Suppose it's 0, 1, 2, 3, and we minus 3 is 0, 1. We need to pop it up. Okay, we need to pop left. Okay. While you need to pop a smaller one, so maintain the monotonic of this Q, and then we just result append the MQ, the first value. Okay. But this should be I index plus 1 greater than k, greater or equal to k. Then we do this. Okay, so let's print the result. Let's see. Let's return the result. See if it's correct. Okay, looks like it's correct. It's if k is 1, just return nums. Okay. Let's see. Okay, it's correct. Yeah. So just I think there are other ways to solve this, but this is the most intuitive one I can think of here. Another one is to go from left to right and right to left and take some maximum number there. I think that is kind of tricky to understand. Yes, this is no, this one. Yeah, it's dynamic programming. It's kind of tricky to understand. But this monotonic deck is really brilliant for this question. Yeah, thank you. See you 39.